Okay. Today I was looking for a lab by Codewars.com about cybersecurity, and I came across with this one called Keyword Cipher Helper. And the interesting thing about this lab is this is the first lab that I worked on data type classes, like class data. Let's look at the problem instructions first. We are working on a cipher, and this cipher is called keyword cipher. It's a very straightforward process or encryption. Basically, as you see here, we are given the English alphabet from A to all the way to Z, 26 letters, plain text. And what we do for encryption is we take this keyword, and in this example, keyword is selected as keyword. It could be cat, dog, but here is keyword. So we write down the keyword characters in the beginning of the string, this encryption string, and then we write down the rest of the plain text, excluding the characters that are already used for inside the keyword. And by doing that, we are making sure that all the characters are used once, and we have this one-to-one mapping. So the easiest way to use that the keyword cipher is, let's say, for a plain text with a character H, the encoded character will be A. H and A will be mapped. So the third from the last character X here, if you encode it, it will be V. Right? Now, looking to the script, the given script, we have this class called keyword cipher. All right, and this underscore init underscore built-in, or this initialization function, shows that we have two attributes: ABC, that's the plain text, and keyword as the keyword that we'll be using to develop the cipher. All right, and then there are two functions called encode and decode respectively. So as expected, encode function uses the plain text and spits out the ciphered or encrypted text, and decode takes this encrypted text and converts it to plain. So we will be replacing these pass statements with valid statement that will help us to do the operations as shown here, or for the first sample test, we will be given the plain text and encode it and get the encrypted text, or we will get the encrypted text and decode it and return the plain text. Now, in this initialization function, what we do is we take these attributes and we assign them to objects. I had this confusion which term I should be using. Will that be instance or object? And in different resources, I see these terms used interchangeably. So I did this search, and basically the term instance in a class is basically the object. So object in a class is called instance. So there may be more deep differences, but for now, that makes sense to me. So basically, we are in this initialization function, we are taking the attributes and assigning them to objects or instances. So we will start with the self ABC. So the convention is using the same wording, right? And we have the self keyword, which is keyword. Now, in order to encode and decode, we need three things. One is the plain text. One is the keyword that we'll be using for encryption. And the third one is the outcome of the plain text and keyword, and that is the cipher key. And cipher key is this one, this string basically. So in other words, we need to know the plain string, which is here. We need to know the string for the keyword, and we need to generate this third attribute, which is the cipher key. Let's call it key here. So I need to define the self key, and that will be the third attribute. But I will do some operations to generate it. So as start, I will take it as an empty string. And what I will do is I will make a for loop for all the characters in this keyword plus ABC string. Okay, so I'm basically taking this term keyword here and adding the English alphabet, and this is the longer string I'm having. But in that string, some letters, in fact, especially the letters, the letters inside the keyword string are used twice. So I need to process it. What I do is that for the characters inside this extended string, I will only append the characters that are not in the key attribute that I started working on. So if I is not in the, or the character is not in this argument or attribute, then I will add the character or append the character to the key. So I will be basically putting self key plus 1. So I will appending the characters that are not already recorded on the self key. And once I complete this for loop, I will have this string generated. Well, this string is only for the sample test. My understanding is that once the code is complete, when you test it, you are testing for the given info here. An attempt is using a different plain text, a different keyword string. So we have to make sure that the coding is correct, which can be applied to different keywords and different plain text. Right? Now, that really finishes the work to be done for this initialization function. We have plain text ABC, keyword, and key attributes assigned to instance here, and that instance is Cipher, because if I look at here, Cipher is the instance using this class with the 2 known attributes. Now, let's talk about this encoding and decoding processes. Well, basically, they are the same operation. It's going 2 ways, so we will just be repeating what we will discuss for each. So encoding will basically take the plain text and also take the key, which we'll work on above here, and we'll encrypt it. Right? So we will have a string called encode. I'll call it encoder. It's a string. And in fact, that's the string that I will return as the final output of that. So, and I should have called it encoded, but I call it encoder. So let me do that here, encoded. It makes more sense. So we are working on an encoded, we will be putting together an encoded string, right? So how should we do that? The first thing that came to my mind is we can have a loop with J on or in this plain text. So here, let's say if this Cipher instance is using the encode function for ABC. In this case, ABC is the plain text. So it will take ABC here. So what I do here is I will split the plain text into 3 characters, A, B, and C, and I'm working on them separately. So starting with the first one, A, I will be looking at the corresponding index number of that letter A on the plain, on this unencrypted text, and I will use that index number to assess, to compute, or to retrieve the encrypted text, right? So let's say n, and here is the index number. So I will be finding out the index number, and that index number, let me fix it first. Okay, that index number n is basically the unencrypted plain text, and I'll be using this index method. I can use it for strings, and I'll be looking at the index of the character J. So the character J is A. I'll look at the index number of A on this unencrypted text. That's the index number. Then I will be using this index number to get this encrypted character. So this is basically, I'm getting this index number and assigning it to the self key, which gives me the encrypted character, and that will finalize what I'm really doing. Well, I will do it for different plain text, different J values. I'll start with A, and I'll look at B and C, and I will append them together. So I will be using this encoded string, and I will add them and make the string longer. So this encoded string will be 3 letters with these encrypted characters. So just to make it shorter, I can take this index number n, copy it, and paste it for this n here. So I get rid of this term n in my code. So I don't need n anymore. Okay. Let me check. I think I made a mistake in here. So I should put parentheses, not brackets, because brackets are for indices, and we cannot use it for because we are not looking for an index here. We are looking at this. We are using this index method, which requires us to put input inside the parentheses. All right, that works. I guess we can record encoded. Okay, so that's really what we would need to do for the encoding process. So I can copy it and go back to the decoding process, and I can, well, I need to process it. So for the decoding part, I'll change this term encoded to decoded, and I will return the decoded value. Okay. And then instead of looking J in the plane, we need to look at this cipher or encrypted text. That also worked. What I need to do here is I need to look at the index number on the encrypted text and get the corresponding value from the unencrypted text. So I'm just doing the opposite of what I've done for encode. So I need to change the parameters to work to make sure that I'm doing the right, I'm performing the right operation. So let's give it a try. It looks that I am on the right track. Okay, so there is an error message here, line 8. Okay, self key, and okay, so there is a problem if not in self key. Can we concatenate string, not integers to string? All right, so do I introduce integers somewhere or strings that are not supposed to be? I'll just take another 10 seconds to find out the potential problem before I stop the video if I have to. All right, for I, if I not in self key, I will append self key. Okay, I think I found there. So I should be putting I, not 1. In fact, that explains why I have this problem, because if I put 1 here, I am appending integers to a string, and it says that you can only concatenate strings to a string. So it should not be 1. So where should I put then? Basically, I'm just appending I values, so that explains. Okay, I think this got figured out. Let's see. All right, so Cipher. Okay, I think there's a spelling error here. Okay, there's no H. Take a look. All right, that works for the samples. If I attempt it, I have everything passed, but here I have an error message, and I cannot go forward and post it finally because the tests are all passed on this work, but I have an error message here, and it took me a while to understand what error message is, but I think I have a good grasp of it now. Basically, it says, if you look at the line 13 here, this line here, it says encoded on this line, substring not found. So in here, what I'm basically doing is I'm looking at the J. I'm looking at this J in this self key here. Let's say here. And if you look at this highlighted, I highlighted for you now, J is given, but I believe on some of the later tests, the code is testing on a more or different strings and different keywords. So there's a chance that this J is actually not in this encryption key string at all. And it says basically here that they cannot find this J in the self key. So we need to put maybe an if statement to correct it. So basically we can say if J is in this self in self key, right? It is inside this self key, then no problem, just go ahead. But if it is not, let's put an else, then don't worry about it. Just take this J directly without doing any encoding, just put it on this encrypted text, because there is no equivalent value, equivalent character in the encryption key. That's a working solution for that problem. And I have to do that for decoding. So I will look at the J in the strings, and if that J is not in this self key, then basically, so it is, if it is in the self key, just decode it. Just make sure that I have, and if not, or else, just use the J value directly without any translation, basically, because basically what we are doing is a translation operation. I guess it works this time. So if I test it, it does, and if I attempt it, okay. Now the error is gone, so it has all the errors fixed. I just need to submit this to get the credit for this operation. All right, thanks for your time.